So far, our work in conservation of energy has focused on gravity. But what about elastic potential energy? Okay? Remember, that's in many ways more relevant to the human body and more relevant to the life sciences because so many of our tendons are, basically springs, right? And they store elastic potential energy in them. And our bones store elastic potential energy. That's why they're not brittle and don't break every time that we jump or take take a tumble, all right? So how can we bring elastic or spring potential energy into this examination of conservation of energy, okay? And to do that, I want to start out by looking at the formula again. So I'm going to call it PE sub E for elastic potential energy. And remind me again, what should elastic potential energy depend on? Well, let's think about it. So just imagine a slingshot, okay? You're going to have more potential energy the farther you stretch it, okay? And so it turns out that the amount that you stretch it, x squared, is proportional to the amount of potential energy that is stored in that slingshot, okay? Secondly, it depends on how stiff the spring is, how stiff the elastic is, right? If it's like just a little rubber band, that'll not going to store a whole bunch of energy. But if it's like tire rubber, imagine that. So the amount of spring constant also determines the potential energy. And then there's this little 1/2 here. And the 1/2 is outside the scope of the course. We're not going to talk about why we get that, but just know that the form of the potential energy for any kind of elastic or spring is given by this formula, okay? And so if you guys go to the next slide, this is, how do we do? Look at that. Potential energy elastic is 1/2 kx squared. We did that, but we already know that. Okay, so let's take a look at how we might use this in a real-world conservation of energy problem. And one story that I love to tell is about this time in India. I did a study abroad there when I was in college, and I recommend study abroads to everybody. You should, if you have the opportunity, do it. Often it's the same cost as your normal semester of college, and it's a great way to just see the world and open up your eyes to things you never would have been exposed to otherwise. But anyways, I'm on this little island in India, and there are these monkeys, okay? And there's all these cute little shops, and people are shopping and buying souvenirs and sweets, and these monkeys are not cute at all. They look like little old men attached to like a fuzzy body. It's really kind of creepy, but they're also terrorizing everybody. They think that everything you buy is sweets, and they jump at you, they rummage through the bag, and they take the sweets and they run off with them, right? So to prevent this, a lot of the shop owners would hire 8 to 10-year-old boys with slingshots to shoot pebbles at these monkeys when they started to approach customers, okay? And so now I was one of the people that actually was attacked by a monkey while over there. What happened was I was holding my little bag that didn't even have sweets in it. It had just like a little tapestry. But I'm holding it, I'm walking with my little tapestry. This monkey sees me, okay? And he's like, looks like sweets. And then he runs over and he starts grabbing the bag. But I'm like, no, hell no, monkey. And I like start pulling it away, right? And then the monkey's like, okay, I'll up the ante. And he jumps on my chest. But the guy with the slingshot wasn't there. He didn't see it. And so I have this like my whole life flash before my eyes. Like I had this like all these thoughts happen in, a fraction of a second. But the main thought was, I bet I could win this monkey at a fight. I bet I could like take this monkey. My second thought was, I don't know anything about the social dynamics of monkeys, and if I attack this monkey, maybe I could win, but what if all his monkey friends then attacked me? Doesn't work, right? So I then threw away the bag, and he went and he saw there was no sweets, and he gave it back to me. But the question that I think is more interesting for this lesson is, what would have been the speed of a pebble had that guy actually, the little kid, slingshot the monkey before I got to it, okay? And so, well, let's do it. So we have a little slingshot here, right? And there's a little pebble in it right there, okay? So I want to know if he were to extend this guy by I don't know. Well, like, what's a typical amount that someone might extend? Maybe a half a meter, right? A slingshot. So I'll do x equals 0.5 meters. Okay. And I will say, well, actually, I did just go ahead and look it up before I got on this lecture. And it turns out that, an average slingshot will have a K of about 300 newtons per meter. Okay? And so my question is then, what will be the speed of the slingshot, or of the pebble once it's released? All right. Well, let's see here. I would do this like I would do every single problem. I start out with E1 equals E2. And what kind of energy did the little kid with the slingshot start with? Well, he started out with elastic potential energy. It was all stored up here. This is the 1, and this is the 2, right? So stored potential energy, that is going to be elastic potential energy. And what kind of energy does the pebble have after it's released? Well, at this point, there's no more stored energy. We're not going to worry about height because we're going to say that, it's shot and released at the same height, so there's no change in potential energy. So we just have all kinetic energy for this guy afterwards. Okay? Third step of any conservation of energy problem, we plug in our equations. We know that the equation for potential energy is 1/2 kx squared. Okay? And we know that the formula for kinetic energy is 1/2 mv squared, right? Right away, we can see that these 1/2s cancel. So we have kx squared equals mv squared. And we need to know what is the mass of that pebble, okay? Well, I don't know. I would say a typical stone probably has a mass of maybe 50 grams, let's say, a typical pebble. So let's say 50 grams, which will be 0.05 kilograms. Okay? So my K is 300. My X is 0.5. And my mass is 0.05. And I want to solve for V. Now, here's the problem. My calculator is in the camera, which is recording me right now. And so I don't have an answer for you. But I would love for you to put this in your calculator and see what the speed of a pebble after the slingshot is. But the important thing is you know how to calculate it. Okay? I will see you in the next video for the wrap-up, the Why Do We Care finale.